Okay, let's start the characteristics of Java. Java is a very easy to learn programming language. It's very simple. Okay, to learn Java, no need of any prerequisite. And the complex features in other programming languages. For example, in C, pointers is a complex one. No, those things are removed in Java. So Java is very simple to learn and a platform independent. When you compile a Java program in one platform, okay, a platform in the sense the combination of the hardware and the OS. Okay, suppose you have a machine with the Intel and Windows platform. Okay, and you compile a Java program in your platform, that is a Windows and Intel. Now the dot class file, after compiling, the source code will become a bytecode, that is called dot class file. That same dot class file will execute in another platform. For example, the platform like Mac OS with Apple MacBook, that is another platform, or any Linux server, that is another platform. So once the program is compiled in one platform, can also be executed in another platform. The same dot class file. Okay, the compiled file. That's possible. That's why they called Java is like Vora, that is write once, run anywhere. Okay, that is platform independent and architecture neutral. Java program will not communicate directly with the operating system or hardware or processor or anything else. It communicates only with help of Java virtual machine, which is there in all the platform. Okay, so we can say Java program is architecture neutral. Okay, the changes made in the architecture is not going to make any impact in the Java program. Okay, so that's why it's called architecture neutral and portable. We can migrate a Java program from one computing environment to another computing environment. Okay, suppose I'm working with a Windows OS and a HP laptop. Okay, the program which I was already doing, no, it's another process. The same program now I can take it and run it in a another environment, which is an AMD processor machine with a Linux platform. Okay, or an Apple MacBook. The same program without even compiling, I can directly shift to another platform. There is another environment. So we can say it's portable. That's why it's portable. The program can be shifted to the another platform or another environment. That's why it's portable. So similar to the mobile portability and all, is there no similar to that. So we can say that this is a computing environment like a Windows PC with a JVM, Linux server. See, environment means Windows PC and a Linux server or a Mac OS MacBook. We can say this is also a platform. So there may be a different platform or different environment, but in everywhere JVM is there. Okay, when you are using a when you want to execute Java, we have to install Java development kit. Okay, along with the Java development kit, JVM software will also be installed. Okay, so in all the platform, definitely a JVM will be there. That is taking the responsibility of executing the Java code. Okay, so here migration means the code which you are typing in one platform or one environment can be shifted to another environment. That is called migration. Okay, but in the previous case, we were talking about the platform independent. Now, there the program is not shifted. The program is compiled in a platform and converted into a bytecode, that is dot class file. That dot class file can be executed in another platform. Okay, that is platform independent. Here, when I'm talking about the portable, the program which is halfway through can be shifted to another environment. That's called portable. So Java is very secure because the bytecode, that is once compiled, the source code is converted to bytecode. No, the bytecode when it is transferred to another platform, there JVM will be there. Okay, the JVM is having a bytecode verifier. Okay, that will check the integrity of the particular bytecode which we received. Okay, if that particular dot class file or bytecode violates any JVM rules, it throw an error. Okay, so the bytecode verifier and the JVM is always responsible to check the bytecode before it is executing. So we can say Java is secure. Okay, hope you got it. And object-oriented programming. See, Java is an object-oriented programming language. We know that. C++ is also like that. So most of the time in Java, we have to handle things in objects, in terms of objects. So Java is absolutely providing OOPS features like inheritance, pulling up with some abstraction and all, and multi-threading. So multiple threads can run simultaneously. Okay, so we can make multiple tasks to be executed simultaneously so that the performance of the application will be improved. So Java is already having a libraries like java.lang.thread and java.util.concurrent. These are all some predefined packages in Java. This is responsible for this parallel execution. Okay, so Java supporting multi-threading, that is multiple tasks parallelly executing, and robust Java program have very less chance of failure in runtime. Okay, because Java is strongly typed language. What is a strongly typed language? See, every variable in Java must have to be declared with a data type. Okay, and Java allow only the value of the correct type to be stored in that variable. Okay, suppose I'm declaring like integer age, then I have to store only the number. That a text cannot be stored. Okay, that way it is strongly typed language. And also the compiler will check for the compile time errors and also for the type compatibility. Type compatibility means, see for example, if an integer is there, okay, that can be stored into a long, because long having a higher range than the integer. Okay, but an integer cannot be assigned to a boolean. Okay, boolean data type will hold only true or false. Okay, so this is called type compatibility. A float can be assigned to the double, that is possible. Okay, whereas a float cannot be assigned to the boolean, that is not possible. Okay, so this is called type compatibility. This is also checked in the compile time itself. And also Java is having garbage collector for memory management. And the variable is declared and it is utilized, later on the particular variable should has to be removed from the memory. Okay, this is automatically done with the help of the garbage collector in the Java. So the memory related problem will not be there. So that's why you can say it's robust. So and Java provides a inbuilt exception handling mechanism. So the abnormal termination of the program in runtime will not happen because of the exception handling. You would have learned this in C++, exception handling. Same exception handling here also. And distributed. Okay, if the application is distributed across multiple JVMs, such application is called a distributed application. Okay, so when you're working with a project where in a Java environment there may be one JVM software, but the project will have different process. Each process can be executed in different JVM process. Okay, so the process is distributed as a different JVM process. So obviously, the parallel execution, everything is happening here, no? So this one of the advantage where we can maintain a load balancing. These are all possible. Failover, everything can be checked. So distributor, compiled and interpreted. See, in Java we have both compiler as well as interpreter. Okay, during compile time, compiler will take care of the syntax errors, the time compatibility checking and all. Okay, and once it is done and compiled into a bytecode, now interpreter will come to the picture and it will start executing line by line, line by. So the interpreter line by line will check the program. So interpreter will play the role during runtime. So compile time, compiler will play the role to check the syntax errors and other thing. And after compiling to a bytecode, now JVM will be coming into the picture, and it will take the bytecode and load it, and it will verify the bytecode and then load it into the memory, and the interpreter will come into the picture and it will start executing it, converting it to the machine code. Okay, so languages like Python, Perl, JavaScript doesn't have a compiler; it has only one interpreter. So errors are rectified in runtime only. Whereas in our case, we Java is having both compiler as well as interpreter. Errors are activated in the compile time itself. Okay, and the interpreter is again taking the role of converting the particular bytecode into the machine code. So Java is having both compiler as well as interpreter and a high performance. When compared with other interpreter language like JavaScript or Python, the performance in Java is really high. What is the reason why its performance is high comparatively? Means Java is having a hotspot JVM. Okay, from Java 1.2 version onwards, they are using hotspot JVM. What is that hotspot JVM? So the hotspot JVM is actually having a JIT compiler that is called just-in-time compiler. This actually responsible for the high performance in Java. How it's working? See, generally, JVM loads the particular dot class file whichever required. Okay, that particular dot class file loader is going to be uh, compiled by the interpreter to convert it into the machine understanding language. So while the interpreter is doing this process, when it found any particular method, okay, is frequently appearing in the code, frequently called in the code for multiple times. Okay, this JVM will take account of it. How many times this particular method is frequently called in the code? Okay, it's taking the count. And now what it's coming to a conclusion is this particular method is a hot method. Okay, so that is actually an hotspot. Okay, and then the JIT compiler, okay, will convert that particular method bytecode into a machine understandable code. Okay, so now what will happen every time when the particular method is called again and again, it won't convert into machine understandable code again and again. Okay, it identified that this particular method is going to be called multiple times. So already it is converted into a machine understandable code, that is machine code. Now directly the interpreter is going to skip that particular converting into machine code because it was already converted into machine understandable code. Now it's going to take that and is going to use it. That's it. Because of that, the performance is increasing because not every time when the particular method is called, every time it's not going to convert into the machine code. You come to know that this method is going to be called multiple times. So based on that, the JIT compiler is converting that particular methods bytecode into machine understandable code. Now next time when the method is called, that conversion of machine code part is skipped by the interpreter. Okay, so directly using the machine code there. That's it. So because of this, the CPU utilization is getting better and it's executing faster. That is one of the key reason for using JIT compiler for a performance increase in Java. And a dynamic in Java program, this all Dockless file is not loaded at the beginning itself. See, in a program, Java program, there may be multiple class. Okay, after compilation, you'll get multiple Dockless file. Okay, the JVM will not load all the Dockless file in the memory immediately. Okay, for the interpretation process, whichever required that particular Dockless file will be loaded by the JVM in the memory. Okay, so that's why we can say it's a dynamic loading. Okay, when it is actually required, only the particular doc class file is loaded, not at the beginning stage itself. So that's it. This is the characteristics of Java. Thank you.